Good morning to everyone. My name is Santosh Kumar and I am very glad to come here as a Optica. Earlier it was OSA, as a OSA traveling lecturer. So first of all, I would like to thanks to a faculty advisor, Professor Iru, to invite me to give a talk on as a Optica traveling lecturer. Okay. I would also like to thanks to Optica NIT Rourkela student chapter to invite me and to interact with this session. Okay. I would also like to thanks to director and HOD of the school to invite me for this talk. Okay. So, first of all, many of us know about the Optica, but still I will present what is this Optica society and what is the purpose of this society. So, in 1916, the Optical Society of America, also known as OASA, was founded by a small group of scientists who wished to create a professional organization devoted to advancing optics, both pure and applied, through scientific meetings, a journal of the highest quality papers, and education program to engage young people. During its 106th year of operation, OSA had successfully grown and transformed to the point where its name and brand no longer reflected the organization work. Renaming the organization was carefully studied by OSA volunteers and staff. After many years of work, Optica, Advancing Optics and Photonics Worldwide, emerged as the best representation of the society. The name change from the OSA to Optica took place in September 2021. Our community embraces change and the reaction to the new name was on the whole very positive, as a board member noted. This is an exciting time for the field and our organization. It's especially gratifying to know that we are all part of the community that looked ahead and the society's future to ensure it will thrive for the next 100 years. Okay. So, this is the Optica. So, its purpose is mainly scientific, technical and educational. Second, vision to be leading global forum for light, science and technology. Third, core values. So, core values, that is the I4, innovation, integrity, and impact. So, here we can see these are the we advance optics and photonics worldwide through different individual and corporate membership, awards and honor, diversity, equity, publications, events, global policy and affairs and Optica Foundation. So, here we can see there are a lot of the members throughout the world, and this Optica society publishes 19 journals of the high level journals, like many of you know Optics Express, Biomedical Optics Express, Photonic Research. Okay. And currently there are over 400 Optica student chapters and throughout the world, and around more than 40 student chapters in the India. This society regularly organizes many conferences and meetings. So, currently there are 24,250 members from 113 countries. In that, more than 60% are members are from outside the US. So, there are different category of the membership, like a student membership, early career membership, individual membership and fellow membership. So, there are total 400 student chapters throughout the world and 23 local sections. So, in that most of the student chapters are in Asia. Okay. So, what are the awards and honors are providing by the Optica Society? There are 16 categories of Optica awards and medals spanning all areas of optics and photonics, that recognizing and celebrating the fields technical, research, business, education and leadership and service accomplishment. So, they are providing the diversity, equity and inclusion. So, they are providing the various opportunity like to become a board directives and initiatives, engagement opportunities, funding opportunities and policies and procedures. So, inspire, support and mentor our students and early career professionals who will be the future change makers in optics and photonics. So, in this society there is one Optica Foundation. The role of the Optica Foundation is mainly to provide a scholarships and travel grants. So, if any one of you want to present your research work in the US or the conferences organized by the Optica Society, you can apply for the scholarship and travel grants and you can attend the conferences. They also provide the fellowship, prizes and competitions, next generation institute, annual fund programs and awards. So, in a scholarship and travel grants, there are 10 opportunities supporting diversity, amplify and cornering women in optical communications, international travel grant, travel for technical meetings, also providing prizes, competition and fellowship. So, there are different kind of the fellowship like Chang Pivoting Fellowship, Dutch Fellowship, Next Generation Institute. They are also regularly organizing different kind of the school, like one is very famous, that is Sigman School on Lasers. So, that is mainly for the laser technology workshop. So, students can apply for that and they will provide the grant to attend that school. So, there are some more different kind of the schools are organizing in winter and summer, students can attend. They are also providing mentor match. In that meeting you can interact with the professors or your experts. A student leadership conference. So, this is very interesting and any one student from the student chapter can go and attend the student leadership conference that usually held in the USA in the month of the October, September and October every year. So, in that is open to all the students, but only one students can go from each chapter. Okay. In that Optica pay airfare, lodging, Frontier in Optics conference registration, some meals. Okay. So, this is interesting because me and Professor Iru 10 years back we meet in this conference and from that we started our interaction and collaboration. So, this is very important in our research area and our job. So, thank you. This was about the Optica, and so I would like to request to your student members, like this year the FIU last registration date is 6th June. So, some of you can interact with your faculty advisor and submit your conference paper abstract, and you can plan to attend the student leadership conference this year. This is my introductory video and I want to show my lab.
基于国家和山东省重大发展战略需求，立足于光通信与信息技术研究领域，坚持基础探索和工程技术相辅相成。光通信与光电
So
子
these are the
交叉融
different
合的发展模
kind
式
of the lab,
先后建
communication
立了
lab
高
and
速光传输、光通
devices
信
and
技术
sensors
等
lab.
各类实验室20余个，总面积为2360平方米，仪器设备总值达5000余万元。实验室现有教授19人，副教授25人，博士53人，形成了一支结构合理、创新能力强、中青年骨干发展潜力大的学术队伍。
So this is me.
三头是库马博士，毕业于印度理工大学，2018年被聊城大学全职引进。以三头是库马博士领衔的研究团队，主要从事基于干涉结构的生物传
These
感
are
器
some
研
Indian
发。
students
此
also
类传感器可在生物医学
came
等领
to my
域
lab
准确地检测
to
出
do the
蛋白
research
质
work.、
葡萄糖等生物分子，利用金、银、
Some of
钠
them
离
Professor
子等
Sahanu
不同
and
类
Nitish
型的
and
纳米材
Lokendra.
料，可有效提高生物传感器的灵敏度，进而用特异性酶
This is
对
cell
传感
culture
器
lab.
探针进行功能化，以提高传感器的选择性。2018年，团队获批山东省引进外国专家计划“一带一路”项目。三头是库马博士研究的光子开关器件及光纤生物传感
These
器
are the some of the
迄
facility
今已
to
在 biomedical、
fabricate the optical fiber sensors.
Optics and Laser Technology 等杂志发表高水平 SCI 论文100余篇，出版专著1部。此外，受邀担任 IEEE、Elsevier 等杂志社审稿人。SPIE 高级会员，在国内外产生了较大影响。
We have a good research platform, a good research team, and a good research foundation. And we believe that with the support of this project, we can achieve good research result and promote the transformation of old and new driving force in the province.
该成果将进一步促进光纤生物传感器领域的成果转化，促进山东省经济社会的迅速发展。利用传感器探针低成本、可重复性的优点，实现快速有效地检测出致褐氏菌，将有效控制我国第3大传染病细菌性痢疾的传播，在医学健康领域助力山东省新旧动能转换重大工程的实施。
Yeah, so this was my introductory video. Now I am going to start the technical talk on wave flex biosensor. So today the topic of the presentation is wave flex biosensor, that is the flexible shaped plasmonic optical fiber sensor for health monitoring applications. Okay. So in this we can see this is our launching city where our institute is, and this is the very water, there are so many lakes and so many, this beautiful city. These are the some of the facility for the optical fiber sensor fabrication and laser technology and devices, and so many of you are familiar. So these are the contents of presentation. In that I will tell about the wave flex biosensor, and then what are the application of the optical fiber sensor, what are the advantages of optical fiber sensors, and about the this our sensors are mainly based on the SPR and LSPR technique. So what are these techniques? And we have developed several sensor for detection of several biomolecules like ALT, histamine, acetylcholine, creatinine, cardiac troponin, cholesterol, glucose, dopamine, uric acid, ascorbic acid, L-cysteine, collagen, p-cresol, and as well as we have also developed a sensor prototype of the sensor for cancer cell detection and bacteria detection. So we will present, I will present few of the sensor in this talk. So first of all, why this is important? So these are the some of the data from the WHO. As per the WHO, you can see due to the cholesterol around 2.6 million deaths occur every year. Due to the liver injury, 2 million deaths occur every year. Similarly, for the cancer, 10 million deaths occur in 2020, and for the diarrhea 0.6 million deaths occur every year. So, how we can reduce this data? So, for that our purpose is to develop portable, scalable, affordable early diagnosis technique that will reduce these numbers. Okay. So, here for this we would like to develop a optical wave flex optical biosensor. Okay. So, what is the optical biosensor? In optical biosensor you can see mainly there are three things. One, sample. So, like if you want to detect the glucose, cholesterol or any biomolecules from our human body. So, for that, for the specific recognition we need the specific biorecognition element. So, like enzyme, antibody, protein, nucleic acid, receptor, these are the biorecognition elements required to detect the respective samples. Okay. So, when the samples and biorecognition element will interact, then there will be some phenomena will happen, and that changes will detect by the optical transducer. So, there are several different kind of the optical transducer that will sense, and that will we can get the signal in our computer. So, based on the variation in the signal we can determine the type of the biomolecules as well as the number of the biomolecules. Okay. So, here we can see there are several application of optical fiber sensor, like in the physical quantity detection, like magnetic field sensor, temperature sensor, humidity sensor and curvature sensor. Similarly, for the biomolecular detection, bacteria, amino acid, cancer cell, protein molecules, as well as in chemical detection, pH detection, chemical reagent, gas concentration, heavy metal ions. So, there are lot of the application of the optical fiber sensor in today's life. So, we can also use these optical fiber sensor in our home to detect the several chemical sensing and biological sensing to keep our family happy. So, what are the advantages of this kind of the sensor over the other type of the sensor? So, first advantage is that biocompatible. This kind of the optical fiber sensor, even we can also insert our human body, or we can also test into the human biofluid that will not react, and we can use it. Reduce size, flexibility and low weight. So, everyone know that dimension of the optical fiber, diameter of the optical fiber is very small, and sometimes even we need to do the surgery. At the place of the surgery we can diagnose through the optical fiber sensor. Low cost, this is the optical fiber is made of the silica. So, that is comparatively cheaper than the other technology. Capability to work in hazardous media, it can also use in the nuclear environment, under sea. Okay. Electromagnetic interference, you can understand this one. So, why this is important? EMI, there is a wire. So, when EMI will happen? When the distance between the both wire will be comparable to the wavelength. Okay. So, in the microwave communication, like the wavelength is in the range of the centimeter. So, in that case there is a chances of the EMI, electromagnetic radiation interference. Okay. But in optical communication the wavelength is in the range of the micrometer. Okay. So, or nanometer. So, in that case the distance between the two cable in the range of the nanometer or micrometer is difficult. So, this is the reason there is a less chances of electromagnetic radiation in optical fiber communication. Okay. Multi-parameter sensing, using the optical fiber we can sense the different like temperature, pressure, different things together. Diversity of light propagation configuration, we can mold the optical fiber as per our need, and we can detect any kind of the things. So, here our sensor is mainly based on the plasmonics. So, what is the plasmonics? Plasmonics is the coherent oscillation of electrons at metal dielectric interface. So, there are two kind of the metal dielectric interface. One is the thin film based and other is the nanoparticle based. So, in thin film based you can see there is a dielectric layer and there is a metal layer. Okay. So, collective oscillation of conduction electron at metal dielectric interface under the influence of incident electromagnetic radiation, some electric field will generate at the interface of metal and dielectric. But in the case of the nanoparticle, nanoparticles means the size of the particle will be less than 100 nanometer. In that case, that electromagnetic radiation will introduce the at the surrounding of the nanoparticles. Okay. So, based on this there are two phenomena, that is the surface plasmon resonance and other is the localized surface plasmon resonance. Okay. So, these kind of the sensor are quite popular nowadays. This is the SPR. Here we can see this is the optical fiber, everyone know this one is the core and this one is the cladding. Okay. So, to make the optical fiber sensor, people are removing the cladding from the optical fiber sensor and optical fiber, and then they are coating the thin film. Okay. So, when we will send the light, then there will be two kind of the wave we will generate. One will be evanescent wave will come outside the this unclad part, and due to the metal and dielectric interface another surface plasmon wave we will generate. So, when the propagation constant of surface plasmon wave and evanescent wave will match, at that time surface plasmon resonance will occur. Okay. So, that is very sensitive to the changes. Okay. If you will keep outside anything, that will change the reflected light. Okay. So, just I have one small video, I can show you how this kind of the sensor is working. Another technique is LSPR. In the LSPR, we need to do the coating of the nanoparticles. Okay. So, in this case we can see this is the one nanoparticles. So, how this kind of the sensor works. So, here we can see this is the output spectrum, and to make a sensor we need to do the coating of the nanoparticle on the optical fiber, and after that we need to attach some of the biorecognition element, like for the glucose detections we need to attach the glucose oxidase enzyme. Okay. So, when we will do the detection of glucose, so glucose oxidase and glucose will combine, react, and that will produce the gluconic acid and H2O2. So, based on the variation of the H2O2 at the surrounding of the nanoparticle, there will be change in the refractive index. Okay. Due to change in the refractive index, that will change the spectrum, or that will there will be a change in the peak wavelength. So, based on the variation in the peak wavelength, we can determine the concentration of the biomolecules. Okay. So, here our lab, our group has developed several different kind of the optical fiber sensor, like MZ dye based sensor, tapered fiber based sensor, multi tapered fiber based sensor, fiber ball, SMF and MCF multi core fiber based sensors. Okay. So, this one you can see these are the there are 7 core in this fiber. So, we have also developed the different kind of the sensor using the multi core fiber, and these are the kind of the wave flex technique. In that you can see this is the double tapered, this one is the humanoid tapered. This humanoid shaped are introduced first time in by our lab, and this is the tapered in tapered and 4T 4 times tapered. So, these are the new shape of the fiber. This is the double edge tapered fiber sensor introduced by our lab. So, there are several different techniques, through that we can develop these kind of the new kind of the optical fiber structure. So, remaining only optical fiber sensor are not very sensitive. To further enhance the sensitivity, we need to use the nanotechnology techniques, like we need to use the several nano materials. So, here we have used the several kind of the gold nanoparticle and the silver nanoparticle for the plasmonic phenomena, and we have also used the other kind of the nanomaterials like graphene oxide, maxine, copper oxide nanoflower, molybdenum nanosheet, and PVA gold silver nanoparticle, copper oxide nanoparticles, MOS2 nanoparticles, graphene oxide and multi-walled carbon nanotube, cerium oxide nanoparticles for the introduce the biocompatibility on the sensor probe. Okay. So, these are enhancing the sensing performance. So, how we can fabricate the this kind of the sensor? So, firstly we need to fabricate the optical fiber structure. So, some of the techniques through that we can change the optical fiber structures to get the more and more evanescent wave outside, and after that we need to synthesize and characterize the several nanoparticles. Okay. So, and after that we need to do the immobilization of these nanoparticles on the optical fiber structure, and after coating of the nanoparticles again we need to verify that nanoparticles are properly attached on the optical fiber surface or not. So, after that to make the specific sensor we need to do the coating of enzyme or antibody for to introduce the selectivity property of the sensor. And then this is the, you can see this is the experimental setup. We need to use the tungsten halogen light source, and this one is the reaction stage, and after that we can collect the spectrum in through the spectrometer in our laptop, and then we can do the sensing, and we can also do the some other kind of the sensing to check the other performance of the sensor. So, these are the typical method to develop the optical fiber waveflex biosensor. So, here we can see how this kind of the sensor is working. So, this is the simple tapered fiber. Okay. So, here we can see in the tapered fiber there are three region. One region is the general region, second region is transition region, third region is tapered waste region. Okay. So, this tapered waste region is our interest, and this will mainly work as the sensing area. So, when we send the light, then we can see due to the tapering the higher modes are trying to come outside. Okay. So, this is called as the evanescent wave. Okay. So, after that we have coated the nanoparticles, to get the plasmonic behavior. Okay. So, when as I told you, when the frequency will match, then there will be resonance will occur. So, and this resonance is very sensitive to the external changes. Okay. So, based on this now I will show the some of the sensors, our developed sensor. So, first one is tapered fiber structure based LSPR sensor for ALT enzyme detection. Okay. So, what is the ALT enzyme? So, ALT enzyme is the necessary liver enzyme and is a type of serum transminase whose activity must be determined in order to diagnose and estimate liver disease. Okay. So, due to the clinical trials and experimental testing have shows that when certain metabolic disorders such as obesity, high fat diabetes and other symptoms that shows and increase the ALT levels in our body. Okay. So, we can determine this ALT enzyme concentration and we can diagnose our liver. Okay. So, normal activity level of ALT enzyme in serum is between 5 to 40 unit per liter. Okay. So, you can see for this purpose our group has developed a new kind of the fiber structure, that is the tapered structure. So, in that purpose we have used the combiner manufacturing system machine to taper the fiber. So, firstly we can see this is the conventional tapered fiber of the 9 micrometer core diameter and 125 micrometer cladding diameter. Okay. So, after tapering, in the tapering method mainly we can see this is the holder, and through the computer program we heat the fiber surface through electrode discharge, and that the same times we stretch the fiber. So, when we heat and stretch the fiber, then that will be tapered like this. Okay. So, firstly we have tapered up to 80 micrometer from 125 micrometer. So, we have also measure the diameter after fabrication, and we found that the diameter is reduced from 125 micrometer to 80 micrometer. Okay. So, after that again we tapered the same surface, same fiber for 40 micrometer. So, this is the reason this kind of the fiber is tapered in tapered fiber. Okay. So, you can see the firstly it was original diameter is 125, then 80, and then again we have tapered for the 40 micrometer. So, this is the step of the optical fiber structure fabrication. Okay. After that we have synthesized the nanoparticles. So, madam already know about the nanoparticles. So, these are the first one is gold nanoparticles. So, in that we followed the turquoise method to synthesize the gold nanoparticle. In that we need to use the gold chloride, chloroauric acid and trisodium citrate, and based on the concentration and volume of the trisodium citrate we can synthesize the different diameter of the gold nanoparticles. Okay. So, after that the firstly we have characterized by measuring the absorbance spectrum. Okay. And its absorbance spectrum is for our case this is around 520. So, that shows around the diameter around 10 to 20 nanometer. Okay. So, similarly we have also synthesized the MOS2 through the MOS2 powder, and we have also synthesized the cerium oxide nanoparticles through the cerium nitrate. Okay. So, these are the TEM image of the gold nanoparticle, MOS2 nanoparticles and cerium oxide nanoparticles. So, after synthesize and characterize of the nanoparticles, we need to do the coating of the nanoparticle on the optical fiber surface. So, of course, we need to follow some of the chemical procedures. So, firstly we need to clean the optical fiber surface through the 3-step cleaning process. Firstly we need to put into the acetone for 20 minutes, then 30 it need to put into the piranha solution for 30 minutes, and again we need to put into the water. So, that process create the OH group on the fiber surface. Okay. After that we need to do the coating of MPTMS. This is the kind of the reagent that work as an adhesive for the immobilization of nanoparticles, especially gold nanoparticles, because in the gold nanoparticle there is a here S group, and in MPTMS there is a SH group. So, that gold nanoparticle attach on the fiber surface through the MPTMS particles. Okay. So, after that we have coated the MOS2 and cerium oxide nanoparticle through the annealing method. So, after that we need to do the coating of the biorecognition elements. So, again we need to follow some of the chemical procedures, like we have used the MUA to introduce the carboxylic group, and then we use the EDCNHS to activate the carboxylic group, and then here this is we have added the enzyme to on the nanoparticle surface. So, this is the complete fabrication process, and after that we need to test that our nanoparticles are properly attached on the fiber surface or not. So, we need to go through the ACM process, and here we have shown the stepwise nanoparticle coating process. So, this one is the optical fiber surface. After that we have coated the gold nanoparticle. So, these are small particles are the gold nanoparticles, and then gold nanoparticles, and then MOS2 nanoparticles, and in this the gold nanoparticle, MOS2 and cerium oxide nanoparticles. So, how we can say that this is the gold nanoparticle, this is the MOS2, this is the. So, for this purpose we need to do the ACM EDX. So, through ACM EDX process, that will tell about the type of the particles. So, this experiment is very interesting, because in this case we are not detecting any biomolecules, we are detecting the enzyme, ALT enzyme. So, firstly for detection of this ALT enzyme, we reacted with the L-alanine with alpha ketoglutamate in the presence of ALT enzyme, and that will produce the L-glutamate plus this biomolecules. So, after that the product of this reaction we kept on the our reaction stage or sensing area, and this sensing area is again coated with the another kind of the enzyme, that is the glutamate oxidase. So, this glutamate oxidase and the glutamate will react, and that will change the sensing spectrum. Okay. So, in this case we have detected the different concentration of the ALT enzyme from 0 unit per liter to 1000 unit per liter, and we found there is a peak wavelength shift, and this is the linear range of the sensor, that is linearity is 0 to 1000 unit per liter. Okay. So, after that we have also done some other tests like reusability, reproducibility, and also the selectivity. So, for the selectivity we have taken the higher concentration and the lower concentration as per the linear range, and we have detected the ALT as well as the other biomolecules that found in the human body, and we found that we are getting the maximum wavelength shift in the case of ALT, not in the other cases. So, why? Because this was the enzymatic sensor, and due to the enzymatic enzyme, the mainly we are getting the changes in the desired biomolecules. Okay. So, this is the another kind of the fiber surface, in that we can see this is the tapered in, tapered, and again there are 4 tapered surface. Okay. So, and this is the experimental setup, light source, and we need to connect the this is the optical fiber sensor which we have fabricated. We need to combine with the some of the cable, and again we need to combine with the spectrometer, and then we can get the output in the laptop. So, I have already explained. Yeah. So, this one is our recent work, that is humanoid shaped. So, this humanoid shaped is first time introduced by our lab, and in that case we have developed a fiber structure of the human shape. This one is looking like a head, and this one it is looking like the shoulder, and this one is looking like the hand. So, in this case we have detected the histamine. So, histamine is a biogenic amine that can accumulate in food during the storage and spoilage, especially in fish and fish product. Okay. So, consuming food with high level of histamine can lead to a condition known as histamine poisoning, which can cause symptoms such as headache, nausea, vomiting, and in severe cases even death. So, this is the reason our group has developed a sensor to detect this kind of the biomolecules. Okay. So, here we can see this is the sensor, and we have coated the gold nanoparticle and graphene oxide and multi-walled carbon nanotube, and diamine oxidase enzyme to introduce the bio specific property, and then we have detected the histamine here. So, this one is the sensor. Okay. So, this is the experimental setup. So, after that we have this one is the sensor surface, and these are the nanoparticle surface, 5 nanoparticles on the fiber surface. We have also done the ACM EDX, and found that the only carbon, that is due to the multi-walled carbon nanotube, and the AU due to the gold nanoparticles are present. Okay. So, here we can see this is the sensing spectrum, and this one is the linear range. So, and we have also tested the reproducibility, means we have detected the same concentration with 3 different fiber surface and we found the same response. We have also checked the reusability, that can we reuse this sensor or not. So, for that we have detected the one concentration, and then we have after a few days we have detected the same concentration using the same sensor again, and we found that we are getting the similar results, means the we can reuse the sensor. Okay. We have also checked the stability, that our sensor is stable or not. We have also tested the pH test. So, at what pH our sensor will perform better. So, we found that our sensor is performing better at pH 7.4. So, our human serum pH is approximately similar. So, it can show that it can, this kind of the sensor can be used for the clinical purposes. This is the pH selectivity results. In that we can see we are getting the higher changes in the case of the histamine, not in the other biomolecules. Okay. So, here we can see I want to, there are several biomolecules. So, I want to show some of the work that is based on the microorganism detection. Okay. So, these are the principle of the biomolecules detections. We have developed several sensor for the cholesterol, glucose and uric acid and other things. We have also developed several different new structures for the development of the sensors. This was the new structure, that is the fiber ball. At the one end of the fiber structure we made a ball, and that ball structure is working as a sensor. So, this was also very interesting, because in this case we have developed the sensor, and then we have also collected the serum. Serum is means that is obtained from the blood. Okay. So, when we give the sample, blood sample for the clinical purpose. So, the mainly extract the serum from our blood, and from that they detected the like glucose or uric acid something. Okay. So, we collected the 5 different serum, and we have detected through our proposed sensor, a developed sensor, and we also detected the same serum through the instrument available in the hospital, and we found that our sensor is approximately working similar to the instrument available in the hospital. So, now I want to say about the cancer cell detection, that is very interesting work. Yeah, just a moment. So, in this work you can see we have developed the multi-core fiber based sensor for the cancer cell detection. Okay. So, here you can see this is the 7 core fiber, 7 core fiber, this is the original 7 core fiber. We have expanded the core through some of the chemical methods, and after that we have used the 3 different kind of the nanomaterials like gold nanoparticles, graphene oxide and copper oxide nanoflower. This is the very new kind of the nanoparticles we have used in this work, and this work was in collaboration with IIT Roorkee and IIT Bhubaneswar. Okay. So, this work was published in Biosensor and Bioelectronics. So, here we can see we have used the single mode fiber and multi core fiber to development of this kind of the sensor, and to introduce the specific property we use the 2-deoxy D-glucose 2-DG over the nanomaterials. Okay. So, here we can see this is the simple method of splicing process, in that we have used the single mode fiber and multi core fiber, and we spliced the small dimension of the multi core fiber, and after that we have etched the multi core fiber to remove the cladding surface to partial removal of the cladding surface, as well as to expand the core of the multi-core fiber. And original, you can see original core diameter was 6.1 micrometer, and we expanded up to around 21 micrometer. Okay. So, here in this case, this is kind of the experimental setup, in that we have used the bifurcated fiber. So, this is the tungsten halogen source. When we send the light, then it will come through the bifurcated fiber to the end of the sensor probe. Okay. This is the sensor probe, and that will interact with the cancerous cells, and we will get the reflected light through the spectrometer in our computer. Okay. So, in this case, we have after etching, we have coated the graphene oxide, then gold nanoparticle, and then copper oxide nanoflower, and then 2 Dg for the specific property. Okay. So, here you can see this is the original multi-core fiber, and with the help of the etching like 6 minute, 10 minute and 15 minute etching, we can expand the core of the multi-core fiber section. Okay. So, and after that we have also tested with the different length of the multi-core fiber and etching, and we found that 10 minute etching is more good for the sensing performance. So, after that we in this case we have synthesized the 4 different kind of the gold nanoparticle, okay, like 10 nanometer, 30 nanometer, 45 nanometer and 70 nanometer. So, as I discussed earlier, we use the turquoise method, in that if you will change the concentration of a trisodium citrate or volume of the trisodium citrate, then you can we can synthesize the different diameter of the gold nanoparticles. Okay. So, these are the, you can see SPR spectrum of the gold nanoparticles. So, as per the diameter, its peak wavelength is also different. Okay. So, in this case we mainly we want to verify the which kind of the diameter is better for the sensing, the lower diameter of the nanoparticle is better for the sensing, or higher diameter of the fiber is nanoparticle is better for the sensing. So, this is the histogram, and the first one is shows the 10 nanometer, this is 30 nanometer, then 45 and 70. So, maybe you are saying that, oh, this is bigger, why this is smaller, right? How teacher is saying that this is 70, this is actually this scale is different. Okay. So, a scale is this scale for this is 10 nanometer, this scale is around 2 micrometer. Okay. So, that is why this size is different. So, we verified, and we found that the 10 nanometer gold nanoparticle is better for the high performance sensor. Okay. After that, we have also synthesized the graphene oxide through the modified Hammer method, and in that we have also measured the absorbance spectrum. In that we got the 2 peak, first peak is at 230 nanometer, and second solder we got at the 310 nanometer, and this is the very high quality of the graphene oxide. And in this work, as I told you, this work was in B&B, biosensor and bioelectronics. So, there are so many things are the novel in this work, and another novelty is the this nanoparticle. So, this is the copper oxide nanoflower we can synthesized in our lab. If anyone is interested, you can refer our paper. So, after that we have done the TM EDS to show that the first one is the gold, the second one is the graphene, and third one is the copper, and these are the nanoparticle coating method I have already discussed. So, after coating, you can see this is the sensor structure, and this one, in this case we have developed two kind of the sensor structure. One is the etched fiber structure, and one is the unetched fiber structure, to compare the what are the changes occur due to the etching. Okay. So, this is, you can see this is the 125 micrometer original diameter, and core diameter is 6.1 micrometer, but the core diameter is not visible due to the coating of the nanomaterials. So, here we can see after etching, its core diameter, its overall diameter is reduced from 125 micrometer to 100 micrometer, and the core diameter is expanded from 6 micrometers to around 20 micrometer. Okay. So, After that, we have these are the different nanoparticles coated on the fiber surface, and we have verified through the ACM EDX that AU due to the gold nanoparticle, carbon is due to the graphene oxide, and copper is due to the copper oxide nanoflower. And apart from that, you can see two other nano material, that is Si and O. So, what is the reason? Because we have done the ACM EDX of the optical fiber. So, optical fiber everyone know that is made of the silica. So, this is the reason SiO2, that Si and O are also come in this ACM EDX. Okay. So, to verify the which kind of the nanoparticle is better, 10 nanometer, 30, 50, 70, we have done the experiment, some glucose detection, and we found that there is high sensitivity in the case of the 10 nanoparticle, 10 nanometer gold nanoparticles. Okay. So, after that we have cultured the various kind of the cancerous cell lines, and as well as we have also cultured two normal cell lines to show the differentiation in the cancerous cell lines and normal cell lines. Okay. So, these are the different liver cancer cell lines, breast cancer cell lines, and kidney cell lines. Okay. And this is the cultural method. We have use the incubator and cell culture lab to culture at the 37 degree and 5% CO2 in the presence. Okay. So, after culture the different kind of the cells, we counted using the hemocytometer. Okay. And after that we dissolved into the PBS into the different concentration from 100 to 10 lakh cells per ml. Okay. So, and after that, so these are the samples we need to detect. Okay. So, after that we have detected the different concentration of the cancerous cell lines, and we found there is a different absorbance occur came into the different concentrations. We have also detected the different kind of the cell lines, and we found in the case of the cancerous cell lines there is more absorbance variation occur in compare of the normal cell lines. Okay. So, these are the linear results. We found that the actually the sample is from 100 to 10 lakh samples. So, we have converted this into the logarithmic scale, and we found that the linear range of the sensor is 10 cells per ml to 10 lakh cells per ml. So, these are the some of the performance analysis. So, we have also compared with the earlier developed sensor. So, the novelty of this sensor is that its linear range is quite high, as well as limit of detection, means the minimum number of the cells can detect. So, we found that for the different kind of the cell, cancerous cell lines and normal cell lines, our limit of detection is around 2 cells per ml, and so that is quite better than the earlier developed sensor. Okay. So, another sensor is microorganism detection is the Shigella bacteria. So, Shigella bacteria, that is mainly responsible for the diarrhea. Okay. So, because we drink the some water, mainly due to the water, and mainly in the children occur this kind of the diarrhea or bacillary dysentery also we can say. So, in this case we have used the this multicore fiber and gold nanoparticle and molybdenum disulfide, and we have used the different kind of the oligonucleotides to introduce the specific property of the sensors. So, as we know, Shigella in the range of 10 to 100 CFU, CFU means colony forming unit, can cause the serious intestinal infection. Okay. So, we have developed the sensor which linear range is 1 to 10 to the power 9 CFU per ml, and detection time is 5 minutes, and limit of detection is around 2 CFU per ml. So, this is the method we have developed the sensor structure, and this is the similar experimental setup we have used. And this one, in this case everyone know, this is very interesting how we grown the bacteria in the lab. So, this is the Shigella sonnei bacteria culture method, in that we can we need to use the two different kind of the food. We need to prepare the food or media for the bacteria. So, one is the media with agar and one with the media without agar solution. So, we need to autoclave to prepare the food of the bacteria, and then we need to agar solution we need to put into the petri dish, and without agar solution we need to put at the room temperature. And again we need to uh, bring the bacteria sample you can buy from the some of the company, or you can also collect from the hospital, and then you can put into the 50 ml media, which media you have prepared. And then we need to, for the different all bacteria need to follow the same process, only need to change the media and the grow time. So, for this kind of the bacteria we need to put into the 37 degree centigrade at 200 rpm for 12 hours, and then again we need to put into the different solution, and to count the bacteria we need to put into the petri dish of the different concentration, and after 48 hours we can that bacteria will grow on the agar solution petri dish, and we can visualize the not we cannot visualize the single bacteria, but when the bacteria will combine, that is the colony forming unit CFU. So, we can visualize through the naked eye, and we can count the lower concentration of the bacteria. Okay. So, these are the conventional method to how to culture the bacteria and count the bacteria. After that we can do the detection. So, you can see this is the gold nanoparticle, this is the molybdenum disulfide nanoparticle. So, we have detected the different kind of the bacteria, and we can see there are different there is changes in the spectrum, and this is the detection time is 5 minutes, and after 5 minutes there is no change. So, that is why we got that we have taken the reading at the 5 minutes. So, these are the other comparison results. So, these are the few books published on the optical fiber sensor in 2021, that 2D material based surface plasmon sensor, that is under the CRC press. So, if anyone want to know about this kind of the sensor or the materials, they can refer this book. And this year we have also last year we have also published one book on the optical fiber based plasmonic biosensor trends, technique and industrial applications. So, this is also very mainly focused on the plasmonic sensors. Okay. So, if anyone want to are doing similar kind of the research, they can refer this book. And some more books are coming in this year. This is in through the SPI, introduction to microphotonics. This is the recent trends on geometric feature based optical fibers SPR sensor. This is also nanotechnology advancement agro food industry. This agro food industry is a very big market and big industry, and how the nanotechnology play a role to for the development of agro food industry, that is also important. So, this book is coming in by the end of this year, and this is about the future optical communication system. And one more good book we are that is coming in this year under the IEEE Wiley, that is the biomedical sensor advanced material approaches anti enhancement strategy, that is in collaboration with the IIT Roorkee. So, if anyone is interested, they can refer our books. So, and these are our national and international collaborators from IIT Roorkee, IIT Bhubaneswar, ISM Dhanbad, IST Trivandrum, MMUT Gorakhpur, MS Ramaiah University Bangalore, MNIT Allahabad, IIIT Guwahati, NIT Nagpur, and of course, Professor, we have just started the collaboration with Professor Biru, but that is not on the paper. So, that is why I have not mentioned here. So, and the international collaboration with the University of Aveiro, Portugal, Northumbria University, London, and Lauching University, and the nearby hospital to just test our sensors, and University of Beijing Normal University at Zhuhai, and the Thailand, and UFES Brazil. So, these are the few highly cited papers. So, thank you once again to everyone to attend my sessions. So, now if anyone want to ask the questions, please ask. And of course, this is not only the technical sessions, you can also ask about the OSA chapter, OSA, how we can strengthen our optical society, NIT Rourkela chapter, how we can take more benefit from the chapters, and how we can join the chapters. If anyone have a doubt, this kind of the doubt you can ask. Yeah. So, madam, first of all, thanks that you have given your time, precious time to attend my lecture. And of course, now this is very interesting questions, and our next focus is the similar kind of the work, like we are using the different kind of the vaccine quantum dots and some carbon nano nitride quantum dot. So, and we are just earlier also I discussed with the Biru, we have a plan to this time to develop the paper sensor. So, in that paper sensor we also we will do the coating of the quantum dots and such kind of the, to mainly get the fluorescence or some kind of the things and through the fluorescence behavior, and we will use the several antigen and antibody to, and then we can develop the sensor for the detection of the several kind of the toxin or some of the bacteria we can use.
Another point is how to use it in practically. Means, say at the bedside, can you develop a portable form of this fiber sensor?
Yeah, this is very also again interesting question, because this one, in this case we in the fiber that diameter is 40 micrometer and like this. So, there is a big problem in the packaging. So, now we are just discussing with some of the company, sensing company, to for the packaging purpose. So, this is the reason we are now we are also developing the paper sensor, that is look like the that is for the COVID detection. We can put a one drop of the samples and then we can detect the one line C line and T line. So, if one line there is a negative and if two line is positive. So, yeah, that kind of sensor is easy to do the packaging and commercialize, but in this optical fiber sensor there is some of the challenges are coming to, because this is fragile, you know. So, if you are trying to package, then it is easy to break. So, now we are facing the issue in the packaging. So, till now these are the prototype we have developed in the lab. Yes, ma'am.
And how it's the sensing process, ultimately you are detecting the intensity. It's not you are comparing the intensity.
Yeah, and there is a, in this phenomena mainly the wavelength change or intensity change, based on those phenomena change in the spectrum, we are determining the concentration and type of the
And
biomolecules.
how it is different from solution phase sensing? In solution phase sensing, even the limit of detection goes very low.
Okay.
So for this type of sensing, how it is different?
This kind of sensor is different.
Actually, in case of solution, there is enough opportunity for the nanoparticle or the fluorophore to interact with the analyte.
Yes, yes,
That is in a dynamic position.
yes, yes.
So this is how it is different. I mean,
Uh,
sensitivity.
Somehow one comparison we can say that if we will in the solution, that will may take I have not worked more, but may take the more time to react in the solutions, and on the optical fiber surface, if you will put the solution, like I told you, for the bacteria detections we got the result in 5 minutes. So, these things these are the some of the advantages we can say in the optical fiber sensor, madam.
And can you sense multiple parameters in a single probe?
Yes, if we will fabricate some two different structure in the same fiber, and of course, if you want to detect the two different or multiple sensing, so of course we need to add the maybe nanoparticle same can work, but biorecognition element we need to do the different coating. Like if you want to detect the glucose or cholesterol, the glucose oxidase or cholesterol oxidase need to do the coating on the same fiber surface. In that case, we can get the two different peaks, okay, and then we can detect. So, some of the people have developed this kind of sensor. We have not developed till now, because we are facing challenges that when we are doing the coating, so both enzymes are mixed together. So, that is why we have not, but some of the who have a good facility that can do the coating only on the fibers of the small different, then they have
So what
developed.
kind of molecular interaction that takes place when it is say in a solid form? This fiber means it is in a solid form.
Yes, ma'am.
So the interaction is quite limited, isn't it?
That is in the fiber, fiber is solid form, but on the fiber, like if you are putting the gold nanoparticle or graphene oxide, so graphene oxide increases the surface area, and that is loaded with the some of the enzymes. Okay. So, when we put the biomolecules like a glucose, that will interact with the enzymes present on the, not on the fiber, with the fiber, that will interact with the enzyme over the fiber. Okay. So, that interaction will change some of the changes will occur, and that changes will identify by the nanoparticles. Okay. And
Some change in the surface plasmonic
yes, yes, ma'am.
pattern,
Yes,
isn't
ma'am.
it?
Yes, ma'am. Yes, ma'am.
Okay, I understand.
Thank you so much for asking the so many innovative ideas also giving.
I have one question. So
Yes,
almost whatever you are doing the work,
yes,
it
please.
is you are identifying or detecting the change of the spectrum.
Yes, yes,
It is a signal.
yes.
If you want to see the morphological information aspect,
Mhm.
then how this fiber optics like what is the detection mechanism? Actually, how you the morphological information you want to see.
In the morphological reaction, like if you want to for the morphological reaction, I think I suggest the other techniques are more good, because in the optical fiber, if you will do the detection, like we have fabricated the optical fibers, and we have kept the other different concentration of the biomolecules, that will react, of course that will react, and some of the changes will occur on the optical fiber surface. Then again of course we need to go for the ACM or some characterization method. So, when we will do the other characterization method, that will increase the prices, and then that will be more complex. So, that is why the through the intensity variation method, we can see the changes quickly. And in the morphological based detection, we need to wait for the characterization, and based on the characterization we can identify. Thank you, Biru.
So, very good afternoon, and although I'm not from engineering background, but I have liked your presentation. I just want to
Thank
ask
you.
a question, like as you have shown, like a book is being published like in agri-food industry. Have you thought of like quantifying the level of toxins that are present in the food products? Because we don't
Yes.
have so much of sensors right now.
Mhm.
Because we know that the food has different matrices, right? And the it's very difficult to optimize or the quantify the amount of toxins that are present in food. So have you thought of anything like how to use this particular probe or this fiber technology in quantifying the amount of toxins that are present in the food products? So have you thought of it?
Yeah, this is very interesting question, and of course, in our book there are several chapter, and one chapter is dedicated for the toxin, and we have also a plan. Like one I shown you the histamine. The histamine is also kind of the toxin that is found in the food, or especially in the meat or something. So, we can develop this kind of the sensor for the detection of the toxin in the foods. So, thank you very much for asking the question.
Now I want to ask like your question. There is like showed the Indian or biological molecules you have attached to the nanoparticles.
Yes.
How they, what amount of nanoparticles and what amount of biological enzymes or biological any molecule attached? How you quantify that?
Yeah, this is very interesting question. So, of course, in the first time we do not know that 5 mg per ml enzyme will be better or 10 mg per ml will be better. So, for this purpose, of course, there are no method for the simulation that we can do the simulation for this kind of. So, these things we can do the experimentally, we can test with the 5 mg per ml enzyme solution, we can test with the 10 mg per micro ml solution, and then we can see the behavior of the sensing performance. Otherwise, secondly, if anyone has done in the other technique like in the electrochemical method and or fluorescence method, they have used the similar, use the same concentration of enzyme, you can directly use that concentration. Otherwise, if you want to verify, we need to do the experiment with the respective concentration, and then we can finalize that this concentration is better for the immobilization, enzyme functionalization.
Next question I want to ask, how you reduce the bulk effect of plastic? Like we will get due to the pH changes and the different material present in the serum, there will be a noise of how.
Yeah, for that like I told you, these are the, we have prepared the solution, these are mostly, these are the artificial solution prepared in the PBS. So, there are no more noise, but still if you will go for the real sample detection. So, in real sample detection, this is the reason in the blood there are so many things or so many interferent that affect the results. So, this is the reason never we are detecting the anything from directly from the blood, we are just by centrifugation we are taking the upper supernatant, that is the kind of the serum, and we are detecting the biomolecules through the serum. So, there are less effect of the noise in that case.
In serum also there are lot many growth factors present which can give different resonance at different velocity. So that was
Yeah, that some of the noise occurs, but for after the some of the signal processing method, we can just get the some of the peak, desired peak, and through that desired peak we can determine the we can say that this is the this concentration or this biomolecules.
another question I have. Can you detect the cancer cells in mixture of cells? Like when you are doing
I
primary taking cells,
Yes.
there will be a mixture of cells, like not only the fibroblasts, not only the.
Yeah, I got your question. Yeah, we have done this experiment. We have mixed, even we have mixed the cancerous cell lines with the normal cell lines, and then we have detected through our sensors, and we can get the different spectrum, and like that will not affect the result. Okay, so that we can do. Yes, yes, we can get the count of the cells, cancerous cells. Yeah, welcome. So, I want to how many of you know about the chat GPT? This is very famous nowadays. So, this is useful or not useful? Yes, because this is the new technology, and now you know this is the open access. So, they have also not made it the perfect, they are also learning and improving this technology based on the our whatever we are doing. So, sometimes like every technology have a side effect, and okay. So, this is also beneficial if you want to just doing research work or something, you can ask few questions, but I suggest you do not believe that this is correct. So, you can also ask can you suggest some papers related to that, then you can go through that paper, you can verify, and then you can conduct the work. Okay. So, because nowadays many AI apps are coming. So, if you say that no, I do not I will not use the AI apps, I am good. So, this is my like if someone will use, then that will do faster work than you. So, it is not that it is not good, you can use if you want, and you can speed up your work, a smart work, you can do a smart work than harder work. Okay. Any question related to the Optica chapters or Optica, related to Optica? Yeah, please ask.
Sir, is it possible that the student chapters of some student exchange programs we can
a student exchange program with
among student chapters.
yes, yes, you can like there is a student chapter at Professor Iru ISC Bangalore. So if you want, or there is a student chapter at IIT Bhubaneswar, that is faculty advisor is Professor Rajan Jha. So you can contact with your faculty advisor. Your faculty advisor will discuss with the respective faculty advisor of the chapter, and you can do the exchange program. You can go there, you can learn something like that.
Then another thing regarding this biosensors.
Yes.
So since we are talking about disease detection, so and we want it to be more sensitive and selective. So is it possible that the vertex biosensor will be as popular as the lateral flow assay?
This is the new technology, and many works are ongoing. So of course, still there are many challenges like packaging and so many things. So if these things will be happen, then of course this will be a better techniques than the others. Thank you. Any other question? Yeah, please ask.
Sir, I want to ask that what are the conditions for these sensors to work?
Conditions, which kind of the condition?
Like if we can use we are using the sensor to detect some biomolecules or microorganisms in the blood. So can we use it like to detect something harmful in the air or something like that?
Yes, even we have also last year we filed one patent that is for the methane, some of the gases, gas detection in the, especially in the mining areas. So we can develop some of the sensor for the different kind of the gas sensor, or some pollutant detection. So we can develop these kind of the sensor.
So what are some of the I mean what are the what
I
is the time taken for the sensors to
Yeah, that vary with the different, like for the hydrogen sensor we need to use the hydrogen sulfide or something on the fiber surface, and in the presence if there will be the different, even we can also develop the oxygen sensor. Okay. And like in the, especially in the COVID period, there was so many changes in the oxygen level. So we can put the some of the responsible things or some of the things on the fiber surface that will especially detect the oxygen or the respective gases. So time that will depend on the specific gases, and of course of what are you using, and the you depend on the your developed sensor. So at this time you cannot say the time, exactly time. Yeah. Welcome.
Sir, one more question.
Yeah, please ask it.
You have shown one biosensor that will detect cancer, right? So at what stage of cancer will it be efficiently able to detect that
Yeah.
biosensor?
Yeah.
Stage 0 or stage 1 or at the later stage?
Yeah. So that stage depends on the number of the cancer cell lines. Okay. So mainly our sensor provides the number of cells in the your blood samples. Okay. So there is some WHO guidelines or some medical guidelines that this number of the lines is present in the blood. This is stage 1, this is stage 2. So based on that, our sensor will only say that in your blood this number of the cancer cell lines is available present. So on the basis of that we can determine the stage of the sensors. Yes.
And another sensor that you showed to detect there was bacteria.
Yes. Yes.
It's a
Yes.
specific type of bacteria. For any other type of bacteria like foodborne or
Yes, we can develop the any kind of the bacteria, but for the, of course for the specific bacteria we need to use the specific antibody. Okay. So and we can use the specific antibody, and we can develop any kind of the bacteria sensor.
so that particular biosensor that was detecting that Shigella bacteria. So is it
Uh,
will be
No, this Shigella bacteria sensor will not work for the other bacteria sensor. Yes, we need to use the, because in this we have used the antibody for the Shigella bacteria. Okay, for the other bacteria, if you want to detect develop the sensor for the other bacteria, we need to use those specific antibody on the fiber surface. Yes.
So by putting the same type of nanoparticles, so we can also
Nanoparticles that will work for the both. Yeah, but only the biorecognition element should be different. Yes.
so it is a permanent bonding that takes place between that biorecognition element and the nanoparticle.
Yes, yes.
Nanosurface.
Yes, yes. We need to follow some of the chemical procedure. Through that, the permanent bonding will occur. Yes, yes. Thank you. Thank you for asking the good question.
Any more question, anyone?
Comparison between the electrochemical sensor and this optical sensor.
Mhm.
How which can be the best one? Because there are any advantages over the electrochemical sensors.
Yeah. Both have the advantages and own limitations. Okay, but nowadays we found that this technique has the more advantages as compared to the electrochemicals, like high speed and less like in the microliter samples we can detect through the optical fiber sensor. In the electrochemicals we need the more volume. Okay, and sometimes reaction time is more in that electrochemicals. In this case the reaction time is slow due to the fast technology. So both have the, but this have the limitation that this is very thin, so fragile. Now packaging is not, but electrochemicals have developed more. So both have own some of the limitations, some of the advantages.
Sir, can we have multiple biorecognition elements in a sensor?
Yeah, we can, madam has asked the same questions. We can use the multiple biorecognition element and we can develop the sensor for the multi-parameter sensing.
So, so then a sensor can detect the multiple diseases.
Yes, we can detect the multiple diseases through the same sensor. Yeah. Nowadays, this kind of the sensor is quite popular, and because people want the same sensor that will work for the many things. So, this is also a popular techniques nowadays. Good. So, how many of you want to go USA this time, this year? Just contact to your supervisor, and if anyone is interested to go USA, no need to pay, no need to just give the any money for the registration fees or for travel or food or anything. Me and Professor Iru attended that free conference in the USA, and they are providing very good quality of the food and also showing some sightseeing. So it will be, this is a very great opportunity, and you can interact with the many high level professors. Okay. So if anyone is interested, just contact with the supervisor. And also one more thing I want to say, that in the Optica there is a one grant based login portal. So you can go to the grant based login portal and give your idea that what you want to organize in your Optica student chapter, and just give them idea that what you want and how much the funding you required. So give the some of the proposal, and they will review your proposal, and that based on the your demand they will sanction the money, and based on that you can you can do many fun. Some you can also organize a school outreach program. You can go to the some of the schools, some elementary schools. You can go and you can design some few light optics experiments, and you can demonstrate to the elementary schools. Okay. You can also do sometimes like pizza party. Okay. Sometimes through fund you can buy the pizza and just celebrate. So there are so many opportunity under this chapter, and okay. So many of our students can plan for this work. So overall, I want that just I discussed with the Professor Iru that of course in last COVID we have not done anything, but now it's time to activate this chapter and to become number one chapter in the India. Okay, of course maybe in the world. Okay, so you can plan for that. Yes, thank you.
sensors and everything. So I would request Shushmita ma'am, Bala sir and Udu sir to felicitate sir with memento and honor him.
Oh, this is a very big honor for me.
Very good.
Yes. Thank you, ma'am.
Okay. Keep it straight, yeah, like this.
Yes, this for you and these flowers I don't know contain to give you.
Thank you so much.